Hi everyone. In our orientation last week, we talked a little bit about the expectations of our class. We'll go into that in a little more detail when we're together, but until then, let's get started. In our very first lesson, we're going to talk about variables and expressions, and these are our goals. We want to be able to identify variables. We want to know the difference between numeric and algebraic expressions. We want to be able to translate words into algebra. The very first thing we're going to talk about are the three types of expressions. There are verbal expressions, which consist of all words. There are numeric, that just contain numbers and operation symbols. And then there are algebraic or variable expressions, which are a combination of numbers, operations, and variables. So let's start with the verbal expression. It's a phrase that has only words in it. Now I can take it out of the context of math and talk about just some everyday expressions, like the expression, it's raining cats and dogs, or maybe once in a blue moon. And perhaps you can come up with one or two of your own that are words that you hear, phrases that you hear people say, catchphrases, or maybe something that goes along with a product. So if you think of one, jot it down in your notebook and we'll share during our live session. Now I can take that also into numbers, and I could just say 4 plus 3 in words, taking it to math class. Now our second type of expression are the numerical expressions, and these have numbers and operations. And here are a few examples. 5 plus 2, 35 minus 12, 4 plus 2 minus 3. And again, numbers, operations, and those are our numeric expressions. Our third type contains a variable. So in order to know what a variable expression is, we need to first define variable. And we know that's just a letter or a symbol that represents a number or numbers. So a variable expression is a phrase that has numbers, operations, and variables. And what we do with these is we will evaluate them. 3x plus 1 is an algebraic expression. It has numbers, variables, and operations. The variable in that expression is x. If I were to tell you x was equal to 3, we could go ahead and substitute in the x with the number 3, multiply it, 3 times 3, add 1, and we'll get 10. And my second expression is 4 times y squared. So 4 times y squared says I'm going to take that y and square it. So what does that look like? I have 4 times y squared, which is 5 squared. Well, 5 squared is 25, so that's 4 times 25. And when I simplify that further, that gives me 100. When I'm looking at your work, I'd like for you to box your answers. In my last problem, I have 2 variables, so I have 2 times 3, and from there I'm going to subtract y, which is 5. This gives me 6 minus 5, which equals 1, and done. Okay? Those are a few examples of our variable expressions and how we're going to work with them by evaluating them. Looking at these 4 problems, I'd like you to pause the video. I would like you to write each of the expressions A, B, C, and D into your notebook, and I'd like you to classify it as a numeric or algebraic expression, and if it's algebraic, then name the variable. Then check back with me to see how you did. Okay, let's see how you did. Numbers and operations, that's numerical. You can use the word numeric or numerical. I interchange the two. My next one, y minus 3. Well, y is a letter, which means it's a variable, so this is going to be algebraic. They want to know what the variable is, identify it, it's a y. Third problem, 3x squared plus 5y. Once again, numbers, operations, and variables, it's algebraic. It asks for me to identify my variables, and this time I have x and y. On to my next one. 36 divided by 4 is just a numerical expression. Sometimes in algebra you will see division written in this form more often than with the division symbol. Every once in a while I'll point out something that we'll see on a regular basis. Now that we know something about these expressions, it's time for us to think about translating. Now, anytime you've been handed a word problem or a situation that you read something that you want to change into an equation or an expression, we find these key words that help us to highlight what operation is going to be performed. Create a 2x2 chart in your notebook. Label each of the boxes with add, subtract, multiply, and divide our 4 basic operations, and come up with as many expressions or words or phrases that you think of that tell you that you're going to perform that operation. This is something that we'll share when we're together, either in a Zoom or in a live session. So please work on that. Before we end today's video lesson, I would like to just model a few of these. We can translate word phrases into algebraic expressions, and you're going to use some of those names that you have in that table that you create, as well as ones that I will be giving you. I hear certain words that remind me of particular operations. 9 more than a number y. Well, 9 more means I'm going to be adding. Now, I could write 9 plus y or y plus 9. That's using your commutative property, so with addition, order does not matter. A number x times 7. Well, you're just going to see something like 7x. You could have it in parentheses. You know that in algebra we don't generally use the times symbol, simply because it looks a lot like our variable x. So our very last activity before you do some independent practice today is to try out these 5 expressions. Once again, copy the expression in your notes along with your translation, pause the video, and check back with me to see how you did. When we're in person, you might come to the board and answer the questions. When we're in a Zoom class, I might ask for volunteers to answer. But since it's a video lesson today, I'm asking you to pause, try them out, and check back with me. So let's see how you did. In the first one, I see the word sum. The sum of 4 and 10 is 4 plus 10. This is a numerical expression. The second one, the product of 7 and y. 7y is an algebraic expression. 9 times 6. Well, I'm going to put these two in parentheses because this indicates multiplication. I could also put a dot in between. Okay, that's another way you'll see it. The quotient of 8 and x. Order matters. Quotient is division, so that's 8 divided by x, or you might see 8 divided by x. Most likely you'll see the first, but both are accepted. The difference of 5 and 1 is 5 minus 1. Now, order matters for these last two because 5 minus 1 is not the same as 1 minus 5. So you see that order does matter when it comes to subtraction and division. I'm going to skip this as a leading problem for our next session. So now it is time for you to practice. I'm a little bit out of sync here. Please complete and submit your assignment. You'll find it on Canvas. And we'll meet up again next class. And until then, have a nice day.